You open the cupboard and grab a plastic container for your lunch. It looks clean. It looks solid. It looks finished. But nothing made of plastic is ever really finished. It just changes shape over and over, sometimes so small you cannot see it happening at all. That container, that water bottle, that cutting board on your counter, they are all quietly shedding pieces of themselves right now. Into your food, into your water, into the air of your own kitchen. Most people think plastic pollution means a bottle floating in the ocean, a bag caught in a tree, something big, something visible, something you can point at and say, that's the problem. But the real story is smaller than that, much smaller. Here is what most people misunderstand about plastic. It does not disappear. It fragments. Sunlight, heat, friction and time break it into smaller and smaller pieces. But the material itself, the chemistry, stays behind. Scientists call these fragments microplastics. That means plastic pieces smaller than 5 millimeters, roughly the size of a sesame seed or smaller, often too small for your eyes to notice at all. And it gets smaller still. When those fragments break down even further, into pieces measured in millionths of a meter, they become nanoplastics. Nanoplastics are so small they can behave less like solid debris and more like invisible dust that can pass through biological barriers your body normally relies on to keep foreign particles out. Why does plastic exist everywhere in the first place? Because it works. Almost too well. Crystal is built from polymers. A polymer is a long chain of repeating chemical units linked together like beads on a string. That structure is what makes plastic light, cheap, waterproof, and endlessly moldable into bottles, containers, fabrics, toys, and packaging. Industry adopted plastic at massive scale in the mid-20th century because no other material offered that combination of convenience and low cost. It was durable, it was disposable, it was, for a while, considered the perfect material. Nobody designed plastic to break apart into invisible dust, but durability and degradation are two sides of the same chemistry. The same bonds that make plastic strong also make it resistant to breaking down completely. Instead of disappearing, it fractures again and again and again, until the pieces are small enough to enter water, soil, food, and eventually your body. So where does this actually happen in your daily life? Synthetic clothing sheds microscopic fibers every time it goes through a washing machine. Polyester, nylon, and acrylic threads that flow straight into wastewater. Plastic cutting boards release tiny shavings every time a knife scrapes across them. Plastic kettles and tea bags can shed particles when exposed to near boiling water. Even the cap on your water bottle, twisted open and closed thousands of times, releases fragments you never notice. Here is the part that surprises people. It is not usually the big, obvious plastic waste that ends up inside you. It is the small, boring, everyday plastic, the kind sitting quietly in your kitchen right now. What happens when these particles get inside your body? This is where the science becomes careful, not dramatic. Most microplastics that are swallowed pass through the digestive system, similar to other indigestible material. But research has detected microplastic particles in human blood, in lung tissue, and in other internal tissues, raising questions researchers are still actively investigating. The World Health Organization has reviewed the evidence on microplastics in drinking water and stated that, based on current research, the health risk to humans appears low at present exposure levels. But the WHO also emphasized that more research is urgently needed, particularly on nanoplastics, because the smaller particles are harder to detect and study. The US Environmental Protection Agency has funded ongoing research into how microplastics move through water systems and interact with living organisms, treating this as an active and evolving area of environmental science rather than a settled question. And a landmark study published in the journal Environment International, led by researchers including Heather Leslie at Vrije Universiteit Amsterdam, reported detecting microplastic particles in human blood samples for the first time. A finding that reshaped how scientists talk about human exposure, shifting the conversation from plastic in the environment to plastic potentially inside living tissue. This is where the term bioaccumulation matters. Bioaccumulation means a substance builds up inside a living body over time because it cannot be easily expelled. Scientists do not yet have a full answer on whether microplastics accumulate this way in humans at meaningful levels. But it is precisely the open question driving so much current research. Picture this scene for a moment. A kitchen, early morning, sunlight through the window. A parent fills a plastic bottle with tap water for their child's lunchbox. Nothing about the moment feels dangerous. Nothing about it looks any different than it did 10 years ago, or 30. And that is exactly the point. The risk, if there is meaningful risk, was never going to look dramatic. It was always going to look like an ordinary Tuesday. Here is the counterintuitive twist. The most persistent myth about plastic is not that it is dangerous. It is that danger would be obvious if it existed. People imagine toxic material as something visibly wrong. A strange smell, a strange color, a warning label. But microplastics do not announce themselves. They are invisible by definition. The absence of a visible warning sign is not the same as the absence of exposure. At the same time, and this matters just as much, invisible does not automatically mean catastrophic. Toxicology has a foundational principle. The dose makes the poison. Trace exposure is not the same as harmful exposure, and researchers studying microplastics are working specifically to determine where that line sits, not to declare that the line has already been crossed. That uncertainty is not a reason for panic. It is a reason for attention. The European Food Safety Authority has published assessments concluding that current data on microplastics in food is still too limited to establish clear, health-based guidance levels, which is a scientific way of saying the picture is incomplete. And incomplete does not mean safe, but it also does not mean unsafe. It means unfinished. So what does this mean for you, standing in your own kitchen? It does not mean throwing away every plastic object you own in a panic. It means understanding the material honestly, reducing single-use plastic where it is easy to do so, avoiding heating food in plastic containers since heat accelerates the breakdown of polymer chains, choosing glass, wood, or stainless steel for surfaces that see repeated friction, like cutting boards, filtering drinking water where possible, letting synthetic fabrics air dry sometimes instead of every load going through a hot cycle. None of this eliminates exposure completely. Nothing can at this point in modern life. But small, informed choices shift the numbers in your favor over time. The real shift is not in what you buy. It is in how you see the material. Plastic was never invisible. It just became so familiar that people stopped truly looking at it. Stopped asking what happens to it after the moment it's used. Stopped wondering where those disappeared pieces actually go. They do not vanish. They just get smaller. Small enough to misunderstand. Small enough to ignore. Small enough to end up back on your plate without you ever seeing it happen. You open the cupboard and grab a plastic container for your lunch. It still looks clean. It still looks solid. But now you understand what finished really means for a material that was never designed to disappear, only to become invisible.